Hey students, so today we are going to discuss the topic of chemical reactions. Okay, when bonds are broken within reactant molecules and new bonds are formed within product molecules to form a new substance. Process that occurs when two or more molecules interact to form a new product. So basically, in simple words, that a chemical reaction happens when the bonds holding old molecules together break apart and the atoms shuffle around to form brand new links and brand new substances. Okay? For example, 2H2 plus O2 is equal to 2H2O. Okay, let's discuss this reaction. In this reaction, basically two molecules of hydrogen react form bonds with one molecule of oxygen to form two water molecules. So a new product is formed. So basically, in simple words, that two molecules of hydrogen and one molecule of oxygen gas is present in this. So, two molecules of hydrogen gas react with one molecule of oxygen gas. They break their old bonds, shuffle, and lock together to form two completely new molecules of water. Okay? So, the next one is basic concept of chemical reactions. Okay. So, basically, students, chemical reactions are not just for science labs, they happen around us every day. Some of the examples are like chemical reaction play an integral role in different industries, customs, and even our daily life. They are continuously happening in our surroundings. For example, iron rusting, making pottery, or fermenting vegetables. So these are basically the everyday examples like iron rusting, baking pottery, and fermenting vegetables. Okay, in a chemical reactions, a chemical change must occur. They change the change are usually physically observed like precipitation, heat production, or color changes, etc. So, basically, a chemical change must happen. You can usually see it with your eyes through clues like bubbles or solids forming, heat being made, or color changing. Okay? So, the here's the next activity which is burning candle. Okay. What happens when you burn a candle? Yes, when you burn a candle, two different types of changes happen at the same time, which we will discuss in the detail. Okay, so when the solid wax melts, it is an example of chemical or physical change. In a physical change, the substances changes state, like hard wax melting into liquid wax. Yes, when the solid wax melt, it is an example of physical change. Why? Because when the hard wax turns into liquid wax, it is just changing its physical state. No new substance is made. Okay? It is still a wax. Okay? Can you give an example of a chemical change when burning a candle? Combustion of fuel in the presence of oxygen produces carbon dioxide. Okay, so the fuel in the wax reacts with oxygen in the air to create carbon dioxide, water vapors, heat, and light. Okay, what are reactants and what are products? Okay, reactants. Reactants are the thing like what you start with, like the ingredients that interact to make something new. For the candle, the hydrogen and carbon from the wax plus oxygen from the air are the reactants. Okay, and what are products in this? Like the newly formed substance. For the candle, carbon dioxide and water vapors are the products. Okay, so here we have the example of okay, let's discuss its golden rule like this. CH4. So basically, this is the reaction. Okay. So the golden rule is that no atoms are ever created or destroyed in a reaction. They just get rearranged into new groups. Okay. So the next one is reactant and product, which I discussed in detail. So Compounds that interact to produce new compounds are called reactants. The newly formed compounds are called products. A reaction can take place between two atoms, ions, or molecules to form new bonds. No atom is destroyed or created, but a new product is formed from the reactants. So, in simple words, the ingredients that interact to make something new are the reactants. For the candle, the hydrogen and carbon from the wax plus oxygen from the air are the reactants, okay? And the products, like what you end with, the newly formed substances for the candle, carbon dioxide and water vapors are the product, okay? Like in this example which I discussed in the detail, like CH4 plus 2O2 is equal to CO2 plus 2H2O. Like no atoms are ever created or destroyed in a reaction, like they just rearrange into new groups, okay? For example, the hydrogen and carbon from the wax breaks apart and combine with oxygen in the air, making hydrogen, carbon and oxygen, which is reactants, okay? They break apart and form new bonds to become carbon dioxide and water vapor. The carbon dioxide and water vapors are the products as well as heat and light from the candle burning. Okay? So, using the chemical formula, this one, you can see that no atoms were destroyed or created, they just rearrange into new bonds. Okay? Okay, here are the activity. Okay. When iron reacts with oxygen and water, what is the product? Yes, when iron, oxygen, and water are react, the product is rust. Okay? If the product is cookies, what are the reactants? If the product is cookies, the reactants are flour, sugar, eggs, butter, etc. Okay? So, rocket fuel called hydrazine can be created in a process using sodium hypochlorite and ammonia to form H2O, which is water, sodium chloride, and hydrazine. Which substances are the reactants and which substances are the products? Yes, as I have told you that reactants are the things that we start with, like sodium hypochlorite and ammonia. And products are sodium chloride and hydrazine. Okay? So, indigo was extracted from plants to make fabric dye until a chemical process was developed to create the dye in a factory. Indigo and acetic acid form when nitrobenzylide, acetone, and water are combined. Which substances are the reactants and which substances are the products in a chemical equation? Okay. So, student, this word is benzaldehyde. Okay? Benzaldehyde. Okay, so the reactants are nitrobenzaldehyde, acetone, and water, and products are indigo and acetic acid. Okay, so counting atoms and molecules in chemical reactions. Okay, how to count atoms? Subscript, like little numbers beside each atom that tell you how many atoms there are. For example, H2O. 2 is a subscript indicating two hydrogen atoms. Okay? Note, if there is no subscript after an atom, the number of atom is 1. Okay? So basically, we're saying that to read a chemical formula, you need to understand two types of number, subscripts and coefficients. Subscripts, these sit to the bottom right of an atom and tell you exactly how many of that specific atom are in one molecule. For example, the example which discussed in the last slide, like in H2O. The small 2 means that there are two hydrogen atoms. If there is no number, it automatically means 1. Okay? Coefficients. Regular size number that indicate how many molecules there are. For example, 3H2O. The 3 is a coefficient indicating that there are 3 water molecules. Okay, to count the number of atoms in a molecule, multiply all subscripts by the coefficient. This will give you the number of atoms of each element. Okay, so coefficients basically sit in front of the whole molecule and tell you how many total molecules you have. For example, 3H2O. The correct way to write this is this: 3H2O, which 2 represents subscript and 3 is a coefficient. Okay, the correct way to write a chemical formula is this. Okay, yeah, okay. So, for example, 3H2O, there are 3 water molecules. Each water molecule has 2 hydrogen atoms. Therefore, the total number of hydrogen atom is 3 multiplied by 2, which is 6. Okay. And each water molecule has only 1 oxygen atoms. Therefore, 3 water molecules would have 3 multiplied by 1, which is 3 oxygen atoms. Okay.